Hello students, so let us start with a new topic. We starting with the analytical principles. Analytical principle. Analytical principles. So we know analytical chemistry is one of the important branch of chemistry. So here we actually dealing with the analysis of unknown compounds. So now a substance is given, you want to identify the substance. So here now what we are using now, the branch is actually analytical chemistry. So we identifying what are the components present in there using suitable methods of reaction or no some other means. So that what analytical chemistry is all about. We classifying analytical chemistry mainly into two that we will call quantitative analysis, and next one is qualitative analysis. Qualitative analysis. So, as the name suggests, quantitative analysis. Here now we are measuring the quantity, how much amount of substance present in a given substance. That what now quantitative analysis is all about. We know gravimetric analysis. There now we actually measuring how much mass of a substance is now present in there. That what now we measuring in gravimetric analysis. So we can say gravimetric analysis is actually a quantitative analysis. Gravimetric analysis is a quantitative analysis. Similarly, volumetric analysis. Volumetric analysis also is an example for a quantitative analysis, where now finally we measuring the volume. Using that volume, we can measure the mass of the given substance in the whole of solution. So both now from that you can identify what is a quantitative analysis is all about. Where we are focusing on the what is the amount of substance given in the sample. Now let us discuss qualitative analysis. Qualitative analysis is just different where we just now focusing what are the components present only. There now we not bothered about the amount of substance. So qualitative analysis, for example, you are given a common salt. There now it is whitish in color. We doesn't know what's now whether it's a common salt or not. So how can you understand if you do some proper chemical reaction or testing, if we can identify a sodium ions is there, chloride ions is there, then we can identify no other component present means no it's a pure sodium chloride salt, that's the way you can identify the given substance is our common salt. So identify the components, what are the ions present in it, what are the atoms or molecules present in it. By that now we can identify the given substance. So that what qualitative analysis, we simply saying these are the components present. For example, we doing a salt analysis in your lab, in your plus 2 level as well, right? In salt analysis, what is your final result? Is your final result is the given substance containing this as anion, this as cation. So you just reporting this is the cation I got, this is the anion I got, so you just reporting it like that. So that is qualitative analysis, where you are not reporting the amount of substance. While now in gravimetric analysis, your final result is the mass of the substance that you obtained. Okay, after a series of reaction, mass of substance, what you got, that part now in gravimetric analysis you are now expressing. Similarly, in a volumetric analysis, we talks about the mass of the substance in the whole of solution. So that's the main difference between a qualitative analysis and quantitative analysis. So let us now discuss about qualitative analysis first. So what is qualitative analysis, and the principle behind it? So in qualitative analysis, we mainly focusing here as the inorganic mixture analysis, inorganic mixture cation analysis. Okay, so what are the cations present in a given substance? So there let us first for understanding the substance, now we are classifying the cations mainly into six groups. There are six groups is there, each group containing this as the specific cations. So if you identify, if you can able to identify a particular group means now you can say the possible cations may be this. After identifying that group, you can able to find the what are the specific cation in it. After identifying group, you have to do some specific test to identify this as the cation. So let us now divide the cations into six groups. Let us now say group 1, group 2, like that. 1, 2, 3, 4, 5, 6. So we divided cations into six groups. So what are the possible cations that you can note? Okay, some important one only I am noting. So cations, the first group now name mainly Pb2 plus, Hg plus, etc. Ag plus, like that. This is the first group cations. Second group now important one I am noting. There is bismuth 3 plus, then copper 2 plus, etc. Okay, these are group 2 cations. Talk about group 3, aluminium. Aluminium is the most important cation in group 3. Aluminium 3 plus, Fe2 plus, Fe3 plus, etc. Fe2 plus, Fe3 plus, that's group 3 for you. Group 4 cations, that is cobalt. The 4 cation you can remember: cobalt, nickel, manganese, cobalt, nickel, manganese, and zinc. This is the group 4 cations. Group 5 cations, barium, calcium, strontium. That is the group 4 cations for you. Similarly, group 6 mainly magnesium. Okay, magnesium is important. Group 6 cation. Okay, so remember these are the, so what's the advantage of classifying into group? Now we can say if you got group 3 means no possible aluminium or iron, ferrous iron or ferric iron may be present. Like that we classified cations into different groups. Okay, now there are specific reagent is said. To get the particular group we are using specific reagent to identify this as a group. For example, group 1 reagent, we talk about group reagent here. Group reagent. So group 1 cations will be precipitated in the group 1 where we using a reagent dilute HCl. That means if you add dilute HCl to the given solution, if some precipitation occur means the group 1 is present and the possible cations are lead 2 plus, Hg plus, Ag plus, etc. Okay, after identify the group 1, you have to specifically go for whether it's a lead or mercury or like that. So that you need to do after identifying the group. So we talk about group reagent means if dilute HCl is added, precipitation occur means a group 1 is present. So dilute HCl is our group reagent. Now let us imagine how the particular metal ion is precipitating. Here now in group 1 the precipitation is okay. They precipitated as group 1 reagent is actually precipitated as corresponding chlorides. So first group is now present is precipitating as chlorides. So after adding dilute HCl, now lead, if it is lead is precipitating as lead chloride, which is now insoluble in that solution. That why it's precipitating as a corresponding lead chloride. So that's the way you can identify group 1. Now this is the way you can understand. Group 1, the given cation, possible cations are lead, mercury, silver ion, etc. And the group reagent is dilute HCl and is precipitating as corresponding chlorides. Similarly, group 2, these are the possible cations and what are the reagent. Very important to identify the group reagent, okay, because now dilute HCl, presence of dilute HCl is required. Dilute HCl plus H2S we will call group 2. Remember, it's very important. Now we have to say dilute HCl plus H2S because when you want to precipitate group 2, it's very important the presence of dilute HCl because the chemistry that I will discuss now later. So dilute HCl plus H2S is our group 2 reagent. Where now you can see after passing hydrogen sulfide gas, group 2 is precipitating. So this is precipitating as corresponding sulfides. So that's the next one. You can remember group 2 is precipitating as corresponding sulfides. Now let us discuss group 2, group 3 reagent. Group 3 reagent is different. It's ammonium chloride and ammonium hydroxide. Remember, now we quickly shifted from an acidic medium to basic medium. Look at this. Group 1, group 2 is all about acidity, acidic medium. Group 3, we now we shifting into basic medium. Please focusing on that because ammonium hydroxide is a weak base, right? Ammonium chloride is a strong electrolyte. So ammonium hydroxide in presence of ammonium chloride and ammonium hydroxide, group 3 is precipitating, that is precipitating as corresponding hydroxide. So remember, it's precipitating as corresponding hydroxide. So after addition of hydroxide, now after addition of ammonium hydroxide, corresponding metal hydroxide is precipitating. So remember, it's very important. First you have to ammonium chloride, then ammonium hydroxide. Why? That I will discuss in the common ion principle. Common ion effect is there. There I will discuss what's important there. So now let us think about group 4. Now remember ammonium chloride, ammonium hydroxide plus now hydrogen sulfide. That part now group 4 reagent is all about ammonium chloride, ammonium hydroxide, and hydrogen sulfide. So look at here, presence of ammonium chloride and ammonium hydroxide. That's important. That should be there in the medium. Then hydrogen sulfide is passing again. Now this time we precipitating as corresponding sulfide. Please note group 2 and group 4 both is precipitating as sulfide. Why they not precipitating together? Why they separately precipitating? For example, bismuth 3 plus is precipitating as corresponding sulfide, while cobalt 2 plus also precipitating as corresponding sulfide, not coming in the group 2, only precipitating in group 4. Why? Let us now quickly note one point. Here, these are in the acidic medium, these are in the basic medium. That's the first point you can note. More we will discuss later. So group 4 we discuss, now group 5. Remember group 5 ammonium chloride plus ammonium hydroxide, ammonium chloride plus ammonium hydroxide plus ammonium carbonate. Okay, ammonium carbonate. NH4 twice CO3. So ammonium carbonate. So these are the reagents: ammonium chloride, ammonium hydroxide, ammonium carbonate. This we will call group reagents of group 5. And remember, it's precipitating as carbonates. Okay, corresponding carbonates. Group 5 is precipitating as corresponding carbonates. So that's what group 5 is all about. Now let us discuss the group 6. Now there no specific reagents are there. Okay, ammonium chloride, ammonium hydroxide, and disodium hydrogen phosphate. So that's just different. There now we do actually do some specific test. Okay, so these are the important group reagents and corresponding groups and corresponding cation. This you have to learn first to go into the principle. Okay, so what are the group 1 reagent? Diluted cell. Group 2 diluted cell plus H2. Group 3 ammonium chloride, ammonium hydroxide. Group 4 ammonium chloride, ammonium hydroxide is sulfide. Group 5 ammonium chloride, ammonium hydroxide, ammonium carbonate. And group 6 we will do some specific tests to identify the presence of these group 6 cation. So now let us focus on the principle. What is the principle behind the precipitation of these cations in their respective groups? Why they are only precipitating in their groups, and what's the importance of addition of these reagents, everything. So we actually remember this keyword. We actually following a scheme for the analysis of these cations. It's not that quickly you do group 1 then followed by group 6 or group 5, not like that. There's a scheme is there. First you do group 1 test. If the precipitation occur, we just separating the precipitate, and using the precipitate we actually do the specific test for the group 1 cations. Like that you have to follow. It's not now you do group 5 then group 3, like that. So there is specific scheme is there that you need to follow for the identification of the corresponding reagents. So let us now discuss the corresponding principle. Okay. So let us discuss first what is solubility product is all about. Solubility products. Solubility products. Solubility product now generally we define for a sparingly soluble salt. Sparingly soluble salt. Sparingly soluble salt means no, the dissolution is very less. The given substance, it's a salt or something, they dissolve the dissolution in that particular solvent is very less. Okay, the amount of solute that dissolved in a specific amount of a solvent is very less. Such salt we will call sparingly soluble salt. But now some part definitely will dissolve, even though they are no less showing less soluble nature, there some part will dissolve. So there is no one particular condition is there where no some part first dissolve. You imagine a more amount of solvent is taken, now some amount of solute is added, so some part it will dissolve after a point, no maximum amount of solute is dissolved. That condition you can call saturated solution. After that saturated solution, there is no more solute going to dissolve in that solvent. So that condition we will call saturated solution. So we define solubility product, in terms of saturated solution. Saturated solution. So what is saturated solution? It's a condition in which no maximum amount of solute is dissolved. That condition you can call saturated solution. Now what is solubility product? Let us not discuss with an example. Silver chloride. Now silver chloride is a sparingly soluble salt. Now when it dissolves in aqueous solution, you can see it splits at Ag plus Cl minus. So this is the way it dissociate into Ag plus and Cl minus. Now what's the point here? First of all, you cannot now I put an equilibrium. It's not a direct reaction. You can see equilibrium reaction is given here, which means silver chloride is now dissociated into silver ion and Cl minus. At the same time, it has a tendency to come back to its original state. Or no, these are, we can say, a substance which is weakly ionizing. The ionization tendency is very less. So that's the point you cannot. Now let us define what is solubility product. Solubility product is nothing but the concentration of ions. Okay, concentration of ions of a sparingly soluble salt in its saturated solution. So KSP. Now how can you write the equilibrium constant? Equilibrium constant is nothing but K is equal to concentration of product divided by concentration of reactant. So concentration of Ag plus into concentration of Cl minus divided by concentration of AgCl. We kept the concentration of solid as a constant. So this part will be constant. So K into AgCl. K into AgCl will be another constant, that what we will call KSP, which is nothing but concentration of ions. Concentration of ions. So understand the key point. Here now this we will call undissociated form. Here you can see there is no dissociation takes place. This is the undissociated form. This is the dissociated form. Okay. If a equilibrium arrow is given, which means both forward and backward reaction can take place simultaneously. Okay, so that means both concentration of AgCl and that means undissociated form and dissociated form will be there in the medium. So that part now you can point it out as the next point. So KSP solubility product is nothing but so concentration of ions. Here ions are Ag plus and Cl minus here. So constant product of concentration of ions in the saturated solution of a sparingly soluble salt. That what now a solubility product is all about. That now you have to remember when you talk about precipitation, because when an ionic product exceeds solubility product, that's the point precipitation is occur. So you can understand some we discuss now group 1 group 1 cations are precipitating like this, group 3 cations are precipitating like this. So when a precipitation will occur, when ionic product exceeds solubility product, when ionic product exceeds solubility products, ionic product exceeds solubility products. So what is ionic product is nothing but concentration of ions. There now we not specifying whether it's a saturated solution or not. So product of concentration of ions, not what ionic product is all about. When the concentration of ions is greater than the solubility product, that means it just passed that saturated solution point. So there more ions are present now. that ions no longer it can dissolve in that solvent, so it exceeds the solubility product condition. That condition where you can see precipitation occur. Precipitation takes place. When an ionic product exceeds solubility product, precipitation occurs. Now let us now think another condition where ionic product equal to solubility product. When ionic product equal to solubility product, no, that's the condition you can say saturated solution. That means no, where maximum amount of solution actually dissolved. So now that condition you can call a saturated solution. Now if the ionic product is less than ionic product is actually less than the solubility products, that condition you can call unsaturated solution. That is unsaturated solution. That condition no, is nothing but no, more amount of solute can be dissolved. More amount of solute can be dissolved. So saturated condition not reached. So that means no, you can dissolve some more salt or substance into the solvent because saturated condition not reached. So that condition you call unsaturated solution. That solution you can call unsaturated solution. Keep this in mind, no, where the precipitation occur, no, when precipitation occur like that. Now, this is the one principle that you have to remember, that is solubility products. Now, when you talks about analysis of mixture of compounds. Now let us discuss another important principle, that is common ion effects. Common ion effect. So these are the 2 points, solubility product and common ion effect. These are the 2 principles that you have to remember when you talks about precipitation of cations. Common ion effect is nothing but, for example, let me explain through an example. Ammonium chloride and ammonium hydroxide. This is the group reagent for the group 3, right? So ammonium chloride is a strong electrolyte that will precipitate as ammonium ion and chloride ion. While ammonium hydroxide is a weak electrolyte, you can see I put the equilibrium state. So it ionizing as NH4 plus and OH minus ion. So remember here common ion effect will come into play where look at this, ammonium chloride also producing ammonium ion, ammonium hydroxide also producing ammonium ion. So after addition of ammonium chloride, if ammonium hydroxide is added, you can see now the concentration of ammonium ion will increase because now already ammonium chloride is there where now ammonium ion's concentration is high is there. So when you adding in ammonium hydroxide, now after that you can see NH4 ion concentration will increase due to the presence of ammonium chloride. Now what will happen? Here now this is equilibrium state where you can apply Le Chatelier's principle. According to Le Chatelier's principle, if you disturb the equilibrium system, the system will act now against it. So for example here now this is the equilibrium state. When you adding ammonium ions, when excess of ammonium ions is there, the system itself try to act against it. That means here this part ammonium ion concentration increases, what system will do, it will shift into the backward direction, so that it want to minimize that effect because in concentration of ammonium ion is increasing, so system will tries to decrease it by now coming in the backward direction. If in the forward direction ammonium ion concentration again will increase, so system will itself try to decrease it. How? By shifting into backward direction. So due to the presence of ammonium chloride, ammonium ion is now concentration becoming larger, so that will affect the equilibrium system. So according to Le Chatelier's principle, if the ammonium concentration ion is increasing, the equilibrium will shift in the backward direction, or now you can see the it will shift into backward direction means undissociated form, or dissociated form becoming lesser, or concentration of hydroxide ion is lesser. So concentration of hydroxide ion becoming lesser due to the presence of ammonium chloride and ammonium hydroxide. Okay. So what the point you have to extract from here, at low concentration of hydroxide, group 3 reagent is precipitating. Okay, low concentration of ammonium hydroxide is required. Okay, so that part now you have to understand about group 3. Okay, now let us now discuss about the first group reagent. It is dilute HCl, and second group reagent is actually this hydrogen sulfide. So first group is HCl and second group is H2S, where now it is precipitating as sulfides, right? So look at here. Here the common ion is actually H plus ion. When you talk about now, after addition of HCl, we passing H2S to precipitating as sulfides in group 2. So here you can see now H plus ion. Here H2S is a weak electrolyte. Remember, H2S is a weak electrolyte, so you have to put equilibrium. So H2S is a weak electrolyte. So after the addition of HCl, then hydrogen sulfide is passing means now this equilibrium system going to be disturbed because now H plus ion concentration is increasing. So the equilibrium system will shift to the backward direction. That means non-dissociated form. Or you can see at low concentration of sulfide ion, what is happening? The group 2 is now precipitating. This time here it is sulfide. This time now this precipitating as sulfide ion. So you can see group 2 is now precipitating as sulfide in acidic medium. Now it's required low concentration of sulfide ions, or now the solubility product of metal sulfide is now less. Similarly, in group 3, you can see now group 3 reagents ammonium chloride and ammonium hydroxide, where low concentration of OH minus ion is only required for the precipitation, and it's precipitating in the basic medium. Now, let us discuss group 2 and group 4. If you look at group 2 and group 4, the reagents are ammonium chloride, ammonium hydroxide, and hydrogen sulfide. So, hydrogen sulfide is a group 3 reagent, where now 2H plus OH minus. This is the way now it's precipitating. Now, sorry, not OH minus sulfide ion, 2H plus S2 minus. So what's happening here? Here now you can think. Here now when hydrogen sulfide is passed after ammonium chloride, ammonium hydroxide, what are the species present in there? Hydroxide ion is there, H plus ion is there. So this H plus ion and OH minus ion actually can combine. This H plus and OH minus ion can combine to form water. So H plus and OH minus coming together, they forms water. That means now the concentration of H plus ion actually decreasing. Due to the presence of these species, concentration of H plus ion is decreasing. Just the opposite of what we saw just before. So concentration of H plus ion decreasing means no system will try to increase. How? By shifting in the forward direction. Now the system will now shift in the forward direction. That means no forward reaction. Dissociated form will be larger, or sulfide ion concentration become larger, and you can see the precipitation of sulfide ion, precipitation as sulfide ions in group 4 reagent. Now after addition of ammonium chloride, ammonium hydroxide, and hydrogen sulfide. What's the point? Here the point is now here high concentration of sulfide ion is required for the precipitation of group 4 cations, while low concentration of sulfide ion is required for the group 2 precipitation. And you can see now the equilibrium will shift into the forward direction, means no sulfide ion concentration will be higher. That means no solubility product of group 4 metal sulfides is actually higher compared to the solubility product of metal sulfides of group 2, because the concentration of sulfide ion is lesser in group 2 and the concentration of sulfide ions is no higher in group 4. Or now when you talk about the group 2, group 4 won't precipitate, because for group 4 higher sulfide ion concentration is required. That's not happening in presence of HCl and H2S. That why only group 2 is precipitating in group 2 cations. While now in group 4 high concentration of sulfide ion is required, and you have to make sure are the group 2 cations precipitated in group 2 itself and doesn't allow to carry it to the group 4. If no group 2 cations is present, now when you analyze in group 4, there is a possibility that no group 2 and group 4 should precipitate. So you have to make sure After the if group 2, remember if group 2 and group 4 is given, you have to make sure group 2 cation is completely precipitated by continuous passing of hydrogen sulfide, and you have to when precipitate is forming, you have to centrifugate the liquid part. Again, you have to pass hydrogen sulfide. Then it will precipitate, collect the precipitate by centrifugation. Again, no liquid part will be there. You have to pass hydrogen sulfide until all the group 2 cations are precipitated. You have to make sure there. Otherwise, no, it may get precipitated in group 4 as well. So after now make sure group 2 cations is completely precipitated in group 2. Then only you have to go to the group 3. Then go for group 4. Never no skip here and there. That by scheme is very important. First you are going to be group 1, group 2, group 3, group 4, group 5 like that. That's the way you're supposed to go. So here one confusion may be there why group 4 cations is not precipitated in group 2, because group 2 cations require low sulfide ion concentration while group 4 cations require high sulfide ion concentration. High sulfide ion concentration not getting in group 2 because of the common ion effect where now sulfide ion concentration becoming lesser due to the addition of HCl and H2S. So low sulfide ion is now required for the group 2 precipitation while group 4 precipitation high sulfide ion concentration is required. So you can see group 4 not precipitating in group 2. So these are the important principles that you have to remember when you talk about qualitative analysis in a cation mixture analysis. Okay. Please go through the question. If any doubt is there, no, you can ask. Okay. So thanks for listening. Let us wind up and more we can discuss in the next class.